Uh, all right, so I'm going to move on quickly to the next part of the questions. So this here is the next part of the question, and just telling us to use set notation to describe the shaded region in each of the following. So for part A, we see that they have shaded A and B. They've shaded everything. So it means they're bringing every element that is A and B together. So meaning that A is just going to be, I have the set A and they're bringing everything that is in A and B together. So that is going to be union B. So that's how I describe that one. That's how I describe that one. Yes, but haven't joined yet. Somebody saying they haven't joined. And people say others haven't joined, or it's different people who hasn't joined. Okay, I think those that are yet to join, they will find us, and of course, there's a recorded class, so they will be able to follow through. But either ways, because of time and progress, we continue. So we have part B here. Okay, see another message coming through. There's different people haven't. Okay, so all right. So those that are somebody to kindly type in the group to say they can rejoin using the link. I do not have my phone with me. Yeah, they can rejoin using the link, the same link. Okay, so at B here, we have P and Q, and we see that the set P itself is not shaded at all. So if the set P is not shaded at all, meaning that has to lie in the complement. So that has to lie in the complement. So that is going to be P complement. Then intersect, look at the part where it is shaded, where Q is shaded. So it has to intersect, I mean, intersecting with what? With Q, because part of Q there is what is shaded, but the entire P is not what is not shaded. So that is P complement, since P is not shaded, so it has to be in the complement. Then intersector QU, because Q is the part where it is shaded. Okay. Do I have any questions on this one? Is anybody lost on how we've gotten the P complement intersection Q? Okay, so let's do part C. Part C is, for part C, I have three sets. That's P, K, and I have P, K, and this is what P, oh no, I have M, N, and K. M, N, and K. And I see that what is not shaded in this case is M. So it's always easier to start with what is not shaded at all. So what is not shaded is what is M, and that is going to be M complement. And it will intersect with the two parts here that are shaded. So in between, what is shaded is the intersection of N and what? And K. So N intersect what? K is what is shaded. And it's intersected with what we're saying here, M complement. Since M is not shaded at all. So this is how this here you can describe it using set notation. Okay, so let's go on further to do the next question. So the next question here we're saying let the universal set. So we're saying let the universal set be. So the universal set is 1, 2, 3, 4, 5, 6, 7, 8, up to 9. And the sets, so I have set A here, set B, C, D, and dot, and F. And they're telling me to find the following there. So I have to find, for question 1, I have to find A intersect C union E. A intersect C union E. So I already have A in the question, so I have to find C intersect E. So what is C I mean C union E. So C union E means I'm going to what? To unite all the elements that are in C and those that are in E. So C is 5, 6, 7, 8, and 9. Then I have that this is with union. So this is union. What is my E? My E is 2, 4, 6, and 8. So 2, 4, 6, and 8. That's my U. So combining all these elements together, I'll have 2, 4, 5, 6, 7, 8, and 9. So this here is my C union E. And they're telling me this here, I must intersect it with what? With A. So I have to say, so my A intersect C union E is going to be, so what is my A? My A from the question is 1, 2, 3, 4, and 5. Then it's intersecting with this, which I found there, which is 2, 4, 5, 6, 7, 8, and 9. So I check now which elements are common in both sets. So elements common in both sets, since intersection, it has to be common in both sets. That is 2 is common in both sets. So 2 there. Then what else is common? 2 and 5. 2 and 5 there are common. So this here is my A intersect C union E, which is given. That's the first one. Okay. And 4. Oh yes, and 4. Yeah, and 4. Yeah, right. I missed that one out. So 4 as well. So I have 4 there and 5. So these 3 here are going to sit in the intersection. So we see that 4 is here and 4 is there. Yeah, almost missed that one out. All right, thank you. So we can move on to part B. So part B, you have to have a bit of understanding of set algebra going on first. So set algebra and De Morgan's laws, I think you have watched that video that Paul has been sharing. So the De Morgan's laws can be stated like this, where we say this. Okay, so this like this. So it can be like this is just equal to A union B, and then complement there. Then also can be written as the same, where you begin with the union complement, and it's gonna give you the same like this. Okay, and also where you say A complement union B complement is just gonna be equal to A intersect B complement, and vice versa, like this. So this is the De Morgan's laws. So the other thing that you notice is, or the other thing that you must notice now being introduced, is the set difference. Set difference, which is like B, they're saying B minus A like this. So this is set difference. And for set difference, you can rewrite this as, this can be rewritten as B intersect A complement. So this is just what the set difference is. So the set difference in set beta notation is just so set of OX such that have X a member of, so in this case we have B minus A. So X is going to be a member of B, and X is not a member of what? X is not going to be a member of A. That's the reason why X has to belong to what? To A complement. And that's the reason why we come up with this B intersect A complement. Okay, so this is one thing you must note, that you can move from B, this set difference here, to B intersect A complement here. The other property to note is when you have A complement with another complement, this just gives you the set A. So this is going to be important here. Okay, so I go straight now. We answer that question. I think that's a bit of a build up that we can do here to help us on forth. So I have my b minus a here, complement like that. So this complement, so I can write what is inside. So what is inside, I can write as b. Then this minus here, or this set difference, can be written intersect a complement, and there'll be a complement outside. So distributing this complement, this sign here always changes. So if I distribute the complement, I'll have b complement. Then this sign always flips or changes. So from intersection to change to union. And this complement by complement just gonna give me what? A set A. So meaning I just have to find B complement intersect A. B complement intersect A. And B complement intersect A is just, so for B complement, these are all elements that are not in B but sit in the universal set. So the set B, you can see it's here, it's 4, 5, 6, and 7. So meaning what is not in what? In the set B but is in the universal set. That is 1 is in the universal set but is not in B. 2 universal set but not in B. 3 as well. Then from there, the next one is what is 8 and 9. So these numbers comprise of B complement. So that's what I have to check. So I'm bringing B complement union what? A. So I now have B complement and I have union what? I have A. So I can bring all these elements together. So what is my A? My A from the question, I have that it's 1, 2, 3, 4, and 5. So bringing these together, I just have, so this here, the final thing that I have is just the same as this BA, the complements like this that I was given in the question. So meaning I can just write that my B minus A complement is going to be, then I unite all these here together since it's union here, as you can see, there's union. So I bring them all together, combine those elements. So I have 1, 2, 3, 4, then I have 5, then 8 and 9. So this here is going to make up that set there. Okay, is that clear? Before we just move on to the next one. Okay, so the next one, we will try to simplify in a similar manner of just what we did here. Okay, so the next one is B. Okay, not B. Next one is A intersect B. Then I have minus B there. So this here is the same as writing A intersect B like this, intersect B complement. Okay, so I have my B complement and I can find my A intersect B. So my A intersect B are the common elements that are both in A and B. So if I look closely, my A here and my B, I see what is common. There's 4 there, there's 4 there, there's 5 there, and there's 5 there. So what is common in both is 4 and 5. So this sits in my A intersect what? Intersect B. Then from here now, what I do is I will intersect it with a B complement, and my B complement is just here up. So which elements are what? Are similar here in both of them. And I see that there are no common elements between these two sets. So which means that this here, the question they're asking for, okay, A intersect B minus B, since there are no common elements between these two, this here is just going to give us the empty set. So that is just going to be the empty set. Okay, now moving on to the next one. Let's move on to the next one. And for the next one, I have it like this. A intersect D complement. So I can write this as F. So F intersect, then I have A intersect D. So there's this complement, but then there'll be another complement because of how I've rewritten the intersection there. the complement and the complement multiply, then I'll just have F intersect, then I have A intersect D like this remain. So this is what I'm looking for. F intersect, then I have A intersect D. So I have to find A intersect D. So I look closely to the set A and D and see which elements are common in both. I can see from here that 1 is common in both, 3 is common in both, and also 5 is what is common in both. So this is my A intersection D. Then I have, it's intersecting here according to this, intersecting with the set F. So I look at the set F and I see where do these intersect. So the set F is just 1, 5, and 9. So where do these two sets, what elements are common in both sets? So there's 1, there's 1 there, there's 5, and there's 5 there. So that is what is common. So meaning this here is just going to be equal to 1, 5. So that's the answer there, 1, 5. Okay, do I have any questions here? Are we clear on this, how we get this? Okay, so this means we can move on. All right, so the next question is more of a proof question, and they're telling us to prove that if P, so they're telling us to prove that if P is a subset of Q, then Q intersect P is equal to P, and then this here Q union P union Q is equal to Q. So this is more of an analytical question. Yeah. So they're telling you first that P is what. So I'll use an approach where it's gonna be a bit abstract. Then I'll just explain the logic behind it, yeah, so that you're able to understand. So what you use, you have to be, of course, it's math, so meaning you have to use logic here. So the first thing they've given us is that this is our key where we're starting from. So we say since P is what, P is a subset of what, of Q, this means that every element, that is in P is what, is a member of what, of Q. So this is the first statement we're making. Since P is a subset of Q, meaning every element that is in P is also in what, is also in Q. Then if we say, so suppose we let an arbitrary element, let's say an arbitrary value, it's just any, it can be any value, let's say any value, X be a member of, so let X be a member of the set P. So this is just any element. So there can be elements, of course. So B in Q. So by definition of what the statement is made, if it's in Q, then X also has to be in what? If it's in P, then X also has to be in Q. Then if it's in both, then I can see that the intersection of these two is just going to go out to be X, because X is going to be common in both. So thus, the intersection P intersection Q is going to be equal to X. But we said X is just any element, any arbitrary element. So we're saying since X is any arbitrary element, then it means that P intersects. Okay, so the moment. So that would mean P intersect Q. Its Q is going to be equal to P. So since it's any what, X is just any other was this element, then the intersection is going to be equal to what, to P. So why is it going to be that? It's because of this property here that is here. Since P is a subset of Q, so meaning what, and if Q has an element X, meaning if P has an element X, meaning Q also has that element what, X. And since P is contained in what, in Q, so meaning that that element which is in what, which is in P is also in what, in X, and that same element is the intersecting point for both. But since that element is in P, meaning it's going to be the set what, the set P. That's the reason why we conclude like this. Then when we talk of union, it's just the same concept. Every language here, the same language we've used, the same mathematical language we've used, but we state because P, now here it's going to change. We are saying it's P union Q. So we're saying since P is contained in what, in A, so to visualize this, think of it like this and like that. So this is my Q and that is my P. Then the union of this will be what? Will be everything here. So the union of this is going to be the entire thing. This is going to be the union. And I see from what I've shaded, I've just shaded the what? I said Q. So because P is contained in what? In Q, it means that if I take the union and bring all the elements together, I'll just get the set Q. So for the second part, B, you write the same language and then just have a conclusion that we've had, which is that there. Okay. So that answers this question. The next question, they just tell us the Venn diagram below shows A and B. So this is A and B. They're saying copy the diagram and add to your diagram the set N, which is such that N is a subset of A and N intersect B is not empty. A intersect B must not be empty. So I'll copy the diagram. This is they're asking for. Then I have A and B there. So this is my A, that's my B. They're telling me to add a third set, and that third set must not be what? If I intersect it, so that here it's saying that third set N must be a subset of A, but it must intersect with B. And the intersection here, they're telling us the intersection should not be what? Should not be empty. So the intersection should not be empty, meaning here they must intersect like this. So like this. So this is going to be my N. I see that it is contained in A and it is also intersecting with the intersection here is not going to be what, to be empty. So if it was, it would have been empty in a case where if I had drawn it like this, E, then I have two elements there, A and B. Then let's say I just write my set like this. So this here would not satisfy the last condition which is given here, because they've told us that A intersect B should not be empty. But as you can see here, this N here, N is not what, is not intersecting with what, with B. So meaning N intersect B is what, is equal to the empty set. But now they've told me that that should not be empty. That's the reason why I've drawn it like that. Okay, so that's it. This one. Okay, the last and final question to just finish up because of time. We have this diagram here and they're telling us to shade those regions that are there. So I have the universal set there and I have the set A and B. So this is my A and that's my B. And they're telling me the first one is B is A union B. So A union B, bringing everything, all elements A and union B together. And I've seen here, since this is a subset, meaning I'm just going to set the entire set what, A like this. So this is my A union B. Okay, then for the next one, I have this. Okay, so that's A there and that's B there. And they're telling me I must shade B complement intersect A. B complement intersect A. So I must not shade the set B at all, but I must then intersect with what? With the set A. So meaning I'm not gonna shade B, but intersect A, which is okay, so that has produced a repeat. Okay, so like that there outside C. This here is going to be my, like that. That's gonna be my B complement intersect A. Okay, then the last one is I'm not going to shade the union, but I shade the complement of the union of A and B. Okay. Going to shade the union of those two sets. So I have A and I have B there. So complement of these, meaning I'm not going to shade the set A, but I'll shade outside the set A, and that is going to be here like this. So that there is my, this is my A union B complement. Okay, so this is the last question. I don't know if I have any questions as we close this class. Do you have any questions? Okay, there are no questions that are being asked. All right. Thank you very much, guys, for attending. And sorry for the inconvenience where we had to restart the class. So work on that such that we're able to have a continuous class. All right. Thank you very much. And I'll see you in the next class, which is tomorrow.
Same time.